Okay then, last time we took our final look at new features in the C#10 language, and now we're moving on to looking at some new features in .NET 6. And the first one we're going to look at is some enhancements to LINQ. Now when I say LINQ, I don't mean LINQ as in the actual keywords in the C# language, because that would be a change to the language. This is simply some additional extension methods which all count as part of LINQ that we can use with .NET 6. And so what I've put together here is I've got this thing called my collection, and what this is just a simple collection class wrapping up a list and then implementing IEnumerable. But I've implemented IEnumerable through my own enumerator. Now I did a video on this a little while back, I'll put a link up to that, but the reason I've done it like this is not because you do this in practical programming, but because I wanted to write my own enumerator so that I could put that line, the console.write line, on move next, so we can see when move next is being called. Because if I then go to my program, you can see here that I'm simply creating one of these collections, generic for person, so I've got a simple person class that just has a name, an age and an ID, and I've given it a toString, and I'm populating my collection with a number of persons and then returning that. And then here in main, I just get hold of that collection, loop through, and if we run that, we can see we obviously get them listed out, but also we get that move next on the for each loop, because each time you take a step through an iteration, you get the move next. If you're doing something like iterating through the loop, you can't avoid that. But in other situations, if we want to write efficient code, we want to minimize the number of move next that we have for any particular operation. And we'll be looking at that in some of these features that have come in with .NET 6 LINQ. But for now, I'm actually going to remove that because it's not something that's going to feature in the earliest examples. Because the first thing I wanted to show you actually was just a situation that's caught me out a number of times and required me to do a bit more work than I might expect, and that is the fact that one of the LINQ extension methods we have is called max. We've got a max and a min. I'll focus on max, but it works the same for min. So what I'm going to do is just do a var oldest equals and then people dot max, and then you can see it's already suggesting what I want. I'm going to have that max, and then we use a lambda to say I want the max on the basis of age. We can't simply do max on its own because that would be meaningless when we're dealing with a person. And you can see it just gives us an error saying it's got to implement iComparable, which obviously we could do, but I'm going to change that to saying by age, and then what we'll do is just print out that oldest, and when we run that, we can see we get the oldest age is 36, which is obvious enough from that data. But that's kind of where we've got a slight problem, because it may be I wanted to know the age of the oldest person, but what if I wanted to actually know the oldest person? Not their age, but the whole person object. And that's one of the things that's been introduced. As well as max and min, we've now got MaxBy and MinBy. And that does precisely what we want. It still uses age to do the comparison, but it now gives you back the object with that age, not simply the age. And so now when we do that, we can see that the oldest person is Fred, aged 36. And so that's quite a nice feature that I've certainly had need to use in the past. And you could make it all work with more code, but now it's in there in the one function. There is a slight logical question about that though, because what if I go back to my data here and let's put in a different person, but with, let's say, the same age, the equal maximum age. Now, if I just did a max on that, that would make perfect sense because we'd still get the maximum age as being 36. But if I do the max by, what does that actually mean? I'm asking for the person with the maximum age. Well, I've got two people with the maximum age. And in fact, all max by is going to do is just give us the first one. So it's found the maximum age is 36, the first person is Fred, and so that's what we've got there. So not necessarily something we're going to be using all the time because of issues like that, but it can be helpful in a number of situations. That actually leads us to another new method that we have in .NET 6, in fact a collection of them, but we'll focus on one of them. Now that we've got this collection of persons with the extra one Dino with the age 36, another thing that we can do with this is we can do distinct. So I could say something like this. I could say for each var p in people dot distinct, and then again just do a console write of p, comment out this just to save as a bit of clutter. But the problem here is we're still going to get the 5 of them out, because if you just do a distinct on a collection of classes, of reference types, all it's going to do is actually look at them to see if they are different objects, and they all are different objects, and so nothing happens. But what we also have is DistinctBy, and that, rather like MaxBy, then allows us to specify what it is that's going to make it distinct. And so we're, again, in this case, going to say p gives p.age. And so now we'll see we get it down to 4, and it's cut out the duplicate by age, which was the extra one Dina. Again, we might say, well, is that really logically what we want? Because they're not really distinct. But if we're saying they're distinct by age, then that's all it can do. It just gives us the first one with that age. And in fact, we have lots of these, because related to distinct, we have methods such as union, and we've also got except, and we've also got intersect, and each one of those, as well as the original version, has this by version which does the same sort of thing. So we can determine the identity based on a selected property rather than on the entire object itself. So quite a few of those. Also with all of these, we have an overload. So if we look at DistinctBy, you'll see there is an overload that can take a comparer. So in the case of DistinctBy, it's an equality comparer. If we look at it on there, it's just a plain old comparer. But either way, it means if you want to do a really precise comparison, so not just using age to see if it's the same or greater than or less than, but maybe combining two things to make your key that's going to do the comparison, then you've got that option available on all of those. And also, actually, another addition is on max and min themselves. They've now got an overload that takes this idea of a comparer. So we can really take control of those if we want to. So that was our MaxBy and MinBy and DistinctBy and other related features as well. Next I'm going to look at, remember something we looked at again in an earlier video, came in C#8, was the idea of ranges and indices. Well, those are now also well integrated into the LINQ extension methods, because what we've always had in LINQ is the ability to do an element at. So I could just do a simple console write, and then I could do people dot and then go for element at, and then let's just select person number 2. So it works like an indexer into an array, except we don't have an indexer on people. And if we run that, we see we get Betty, simply because Betty was number 2 in that collection. But what we also had with this idea of indices is we can count in from the end. So if I put hat on there, so remember hat means from the end, and we had that working with arrays and things like that, but now we've got this added to the element at. And so if I do that, we can see we get Dino as 2 in from the end. So that's something else that we've got in there. That also relates to another useful thing that we've got, which is we can, on a take, we can do ranges. So what I could do here, I could say for each var p in, and then I could say, well, what I used to have to do would be something like this. I could say people.skip1.take2. So that means don't start at the beginning, move in 1 from the beginning, and then give us back the next 2 elements. So if I just do console write of p there, we can see we get Wilma and Betty because we've moved on 1 from the beginning to get Wilma, then we take 2, so we've got Betty. But now I can simplify that, and it's not a huge improvement, but it means I could now do take 1.3, because it's the exclusive upper bound, so we've got to put a 3 in there, and then I can get the range in that way. Really just a slight simplification, but indices and ranges we've got. And I can also do something like 1 ... maybe hat 2. So go from 1 to 2 in from the end. And actually that gets the same result. If I did 1 then hat 1, that would give us the extra 1 in from the end. So we've got all sorts of things like that that we can just simplify with. Now, I mentioned back at the beginning that one of the things we're going to look at with these is how they affect performance. So let's get on and do that, because something else we can do with the collection is we can simply have the count extension method. So if I do console write and then just do people dot count. Notice we don't have a count property because that's not one of the things I've implemented, because IEnumerable doesn't require to have a count property. But even if we don't have it, we're still lucky enough to have the count extension method. And so when we run that, that simply tells us that there are 5 elements in the collection. But now let's look at how that's done. Because if we go back to the collection and put in that move next, and then run that, we see it actually has done move next 6 times. Because if you don't have an actual count property, then the only way that you can work your way through and count up the number of elements is going through them one at a time. And you can immediately see that could be horribly inefficient, particularly if you've got 10,000 elements. That's going to be quite slow just to get the count. Now, there is a way around that in that there are more interfaces related to collections than just IEnumerable. In fact, the one that we need for this is called iCollection. So if, as well as implementing IEnumerable, I could implement iCollection of t, you can see it then gives us some errors because we've got more methods that we need to implement. But what I can then do is, very nicely, Visual Studio allows me to implement through the member underscore list. So I won't have to write any of this code. I'll just hit that, and it gives us the various methods that are required by iCollection, which are things like contains and clear, copy to, remove. But the important one, as far as we're concerned, is we have this count. So now we've got a count, and because it is implemented through underscore list, it just gives us back the lists count. And a list, bear in mind, underneath the covers, does know how big it is. So a list doesn't have to step through to do the count. It actually has that value directly. But now that we've got a count property, now when we call the count extension method, we're not getting any of those move next. We're just getting the number 5 read directly out of the list. So much more efficient. The way that the count extension method actually works is it uses reflection to query the people object as to whether it implements the iCollection interface. And if it does implement it, it will call the count property, assuming that's more efficient, which it is in this case. But if it's not available, then all it's got available are the methods of IEnumerable, and that's why it has to step through and do it inefficiently. And it does it in complete silence. So it's something to watch out for in terms of performance. You won't know there's a problem unless you actually notice it running slowly or put in some kind of debug code like I had here. So that's one way around it. But let's actually take this back. This was nothing new in .NET 6. That's just how things always work. So let's take it back to where we were. And we've got that count. So that's again going to give us the move next. But what is new that we have in .NET 6 is I can do this. I could actually say here, if, and then people dot, and then we're going to call this new method, try get non-enumerated count. So it's a bit of a mouthful, but it does explain what's going on. It's going to see if this particular collection actually does support a direct count property. So non-enumerated. The enumerated count is when it's having to go through move next lots of times, and we can see it's done that. So we'll let the code get filled in. And so what it does is, as the try implies, it returns true or false to see whether a non-enumerated count is supported, and if it is supported, then it will put that value into count. So what I can now do is here just do a console write of count, and then else, and we'll just say not supported. Okay, so now at last we do effectively have a way of testing whether it's going to be fast or slow, not just having to look at the performance. And so now we'll see that if I run that, it's saying not supported because I'd taken off the iCollection. But if I just Control Y that and put it all back in, so now we've got the count and everything else. And so now that's going to return true, and we're going to get that count of 5. So that's quite a nice feature. If you've only got the object, you don't know what interfaces it supports, then you can get it to check for itself at runtime. That also relates to some other efficiency issues, because if I go back to, let's say, the element at, and let's just ask for element at position 4 and run that, you can see although it's getting it, we're doing, again, a lot of move nexts to get to that point. And indeed, if I ask for position 2, say, then obviously it's rather fewer because it only has to go through to that point. But if I ask for position hat 2, then we can see, obviously, it has to move through 4 to get to the 2 from the end. But if I were to remove, again, the collection and therefore remove the count, you have the problem that if it's going to count in 2 from the end, it's got to know where the end is. If it doesn't have a count, it can't do that directly, and so it has to do it the slow way. And so you'll now see that when we run that, we actually get 6 move next because it's got to count all the way to the end to determine how big the collection is before it can move 2 in from the back. So we're now getting multiple stages of inefficiency with element at, particularly if you use the indexer in from the end. If you've just got an I enumerable, then you have to go all the way through. If you've got I collection, then it's a bit more efficient because you've only got to move through to that point because it can work out the count. But even then, it's not the best you can have, because the best we can have, for element at any rate, is we could do a I list. So another interface that we can put in there. And once again, it's very nice in that it will allow us to implement that through the underscore list that we've already got in there. And you can see what that gives us now is the main thing that we're interested in. It's got this indexer, which means we can now directly index into the list. And so what that now means is if we look at the program and go to element hat 2, it doesn't have any move next at all because it's going directly into that indexer. That's what the element at calls. So both with the element at and the count, you have this issue that it's dynamically looking to see if certain interfaces are supported. If they are supported, it uses them and it's all very efficient. But if they're not supported, it will make do with what it's got, which may be less efficient. A couple of other methods that are supported here that are new. Let's just do some commenting out and just show you quickly. One of them is a very minor extension to something that we already had. If I create a couple of int arrays, so let's have A1, and then we can see equals new int, and lovely things we get in Visual Studio 2022, prompting me for what it thinks I might like. And so I'm going to have that as just 1 to 5, and then let's have another one, int array A2, and this one I'm going to have 6, 7, 8, 9, 10, and again it's put that all in for me. So a couple of arrays, and then all we had that's been around for a while is actually a thing called zip. So what I could do is I could say var zipped equals a1.zip a2. And then if we do a for each of var x in zipped, and then let's just do a console row of x. What it's actually done, let's just look at the type of x. X is a tuple containing a first and a second, both ints, and you can see it just zipped them together, paired up those two arrays, those two collections. It'll work for any enumerable type. But what's new, and it's very minor, but it's quite nice, is we now have the idea of zipping with 3 of them. So it's just added an extra overload. So let's change that one to 11, 12, 13, 14, 15. And now we can do a zip of A2 and A3. And now it's a tuple with first, second, and third. And we get the 3 of them zipped. So pretty simple. They haven't gone further with more overloads than that, but it's certainly a slight enhancement that we have. It would be easy enough to do your own to put these things together if you wanted to. Another thing we've got is an idea called chunking, which is something that people like to use quite a lot, but again have had to write for themselves in the past. So what I'm going to do here is just, in addition to my 5 handwritten persons, I'm just generating 1,000 more persons, just called person 0, person 1, person 2 with similar ages. And so we've got a lot of data in there. And obviously I could do a for each of person, person, and people, and then write out the full thing with a 2 string. And if we run that up, then we obviously get all 1,000 of them. But If you're doing anything with paging or things like that, you might want to do things slightly differently. So what I can do here is now say var chunks, and then I can say equals people dot chunk, and let's do them in chunks of 100. So we've got just over 1,000 of them, but we're going to break them down into chunks of 100. And if we look at that, then we can see that what it's given us is an enumerable of arrays of persons. So each one of those arrays is going to contain 100 persons, except for the last one, which obviously might be shorter, it is in this case, and that's how we can do that. So what we can now do is we could say for each var chunk in chunks, and then on each of those I'm going to do a right line new chunk, and then we say for each var person in chunk, and then here I can do a console write line, and I'll just indent that a bit so we can see what's going on, plus person. And so now we'll be able to see that when we run that, you can see it is saying new chunk, and it's doing the 100 groups and breaking it down like that. So a lot of nice new features there, some of which I think I'll probably be using more than others, just see how things go, but certainly pretty useful in many cases. But obviously all the examples I've been giving you there have been LINQ to objects. So we're dealing with objects in memory. One of the really nice things about LINQ, of course, is it works with databases. So let's see how these features work with databases. So let me just turn all of those back on. So let's uncomment everything in there. Okay, and just check that's all building okay. And so that's all building fine. But you'll notice I've also, as well as got this create collection, I've got this create context. So I've got a my context, which is a DB context with a set of people. And you can see here, I'm just very quickly using SQLite as an example database. So we make sure we've got a brand new database, we populate it, and then we return the context. So what I could do here is on my people, I could, rather than saying create collection, say create context, and then on the context we say dot, and then that people DB set we have in there. And we can see, because that's going to be an IEnumerable, that builds, but now let's run it, and you can see it does the very first thing. So remember, the first thing we had was just a for each looping through. But then for every one of the other features, or pretty much every one of them, it is giving us an error, and it's basically saying that the LINQ expression, in this case the MaxBy, could not be translated into SQL. And this is a big example of a fundamental issue we're always going to have with Entity Framework. The fact is that whatever we do in LINQ, there still needs to be an underlying provider that turns that LINQ into a language that the database understands, in this case SQL. And in the case of SQLite that we're looking at here, and I've also tried it out with SQL Server, and as far as I can tell, it's true for pretty much everything else, the providers do not yet have the features to provide SQL for these new LINQ features that we've got in .NET 6. So it's a really bit of a problem there that it's being held back. Now I've had a look around, and as far as I can tell, they may be coming in future versions of the providers. It may be just a question of the time it's taken to get those features in there. But there are issues around performance, particularly something like MaxBy really does require 2 iterations through the collection in the database in order to get that MaxBy, which people argue is inefficient, and therefore it shouldn't be something that the Entity Framework provider provides for you. Whereas the other side of the argument is, well, you know, there's lots of things that are actually inefficient. The point is they're helpful, and as long as you're aware they may be inefficient, you can do it in different ways. It would just be nice if the provider would do that for you when you want to. So there's swings and roundabouts to that. We'll see what happens in the future releases of the providers. But one of them that is worth having a look at, that does work, is actually that try get non-enumerated count. Because if I just comment out all of that and comment out the rest of it to there, then all we're doing that's left is we're printing them out, and then we do this non-enumerated count, and then we do the normal count. And if we run that, we can see it is saying not supported. So because doing a count would require going over to the database, not strictly speaking necessarily enumerated, because the database itself will have some efficiency tricks to get a count from a table, but it's regarded as not being a quick operation, and so it doesn't give us that. So that's one of the ones, and really the only one as far as I can find, that is implemented by certainly SQLite and SQL Server. So that's it for the new LINQ features in .NET 6. Some really nice features in there, I think, things that will make it easier to write code and also easier to write efficient code. Also, we looked at the way that those interfaces have worked for a long time with the extension methods, that the extension method looks to see what interfaces are supported and then does the most efficient thing it can based on what it finds there. But the downside to all this, and I was disappointed when I discovered this, is that pretty much all of these features are not going to work as yet with LINQ 22 framework. But I hope that was helpful. There's lots more in .NET 6 we'll be looking at in future videos. But if you like that, do click the like button, do subscribe, and I'll see you next time.